So this will be about Non-Max Suppression. So we'll be installing first the required libraries, and I have already installed those. So we'll be importing those. Here this is to just check whether I am using GPU or CPU. So this won't be necessary, but let's say I'm using CPU here. So we'll be talking about this method later. I'll run the method here. So I have a labels modified txt file here. I will have the coordinates of the bounding boxes and the confidence of how much confident the bounding box prediction is. So I'll be taking it into a data frame, and I'm also going to add a column named active, which is initially set to true. So we'll observe that each bounding box we have considered would be contained in this data frame. So there are 6 columns: so x min, y min, x max, y max, confidence, and active. And this would be since we have the non-max suppression technique, so initially these labels would focus in an instance where we don't use the non-max suppression technique. So for the same face or for the same object, there will be multiple bounding boxes. So we could check whether it is so. Yeah. So since we haven't used non-max suppression technique when creating these labels, we would get multiple bounding boxes in the same frame. So what I do is here, considering the same face, there will be multiple bounding boxes. So each bounding box I will be considering it as a proposal. So whatever input I took from the labels modified txt, I will be considering it as proposal. So this proposal data frame would contain all the proposals for it to be a face. So I am having a copy of it, and this is the output, which would be only the accurate bounding box which would represent the face, the single bounding box which would represent the face. So there are 9 faces, so output should contain around 9 bounding boxes which represent the faces. So here we have an IOU threshold value. We will be looking at it as well. So initially everything is set as active equals true. So we will be focusing on this algorithm until the active bounding box is set is empty. Until when there are no active bounding boxes. So in the meantime, we will be setting the active bounding boxes to false inside the algorithm. So initially you will be getting the proposal data frame, and inside the proposal data frame we will be considering only the active bounding boxes. We will be considering the confidence, and we will be getting the maximum confidence. So we will be getting the index of the element which has which is the maximum confidence. So we will be considering the active bounding boxes, we will be considering the column confidence, and we will be getting the index of the maximum value which we find inside the confidence. So the maximum index would give the row number here, row number which would row number inside the proposal data frame which would have the highest confidence. So using the row number, we could get the row which corresponds to the maximum confidence. So the maximum confidence proposal, we will be adding it into the output. So here we are adding it into the output. We will be converting into a data frame, and we will be adding it to the output. And while adding it to the output, we will be removing it from the proposal as well. So from the proposal data frame, we will be removing it. So instead of removing, I have deactivated it. I means active, I have set it to false. So since we are considering only the active frames here, when we set it to false, here it won't be considered when relooping as well. So once we get the maximum confidence proposal, we will be looping it with other activated bounding boxes. So since we have deactivated the bounding box we are considering, so the bounding box we are considering and the bounding box and the same bounding box won't be considered in this loop. Since we have deactivated here as false, those won't be considered. So if active is false, we will be continuing, we won't do any operations here. So if it is not the same bounding box, we will be getting the BB intersection of a union. So that means the intersection between two bounding boxes over the union between two bounding boxes. So that ratio we will be taking into consideration. So once considering that threshold, IOU threshold value, we will be comparing it with the IOU threshold, and if it is greater than the IOU threshold, we would be deactivating it. That means if we have two bounding boxes, and if it is overlapped over another, and when we consider the two bounding boxes beyond a certain percentage, here 0.2 means that's around 20%. So if it is overlapped around 20%, if it is overlapped greater than around 20%, we will be considering it to be the same box. So if it is the same box, we need to remove that extra bounding box which has lesser confidence than the one we considered here. So since we considered the maximum confidence one, so this would be the lesser confidence ones, so we need to remove those. So similarly, we will be considering the next maximum proposal, and we will be comparing it with the others. So the next maximum proposal, we will be comparing with the others. So similarly, we will do this loop until there are no active bounding boxes. So what would happen is, we will be considering that there would be a maximum confidence here, maximum confidence bounding box here, maximum confidence bounding box here. Similarly, there would be maximum confidence bounding boxes. So we will be comparing it with the other bounding boxes, and we will be removing other bounding boxes which represent the same phase. And also, after we run this, I think we could visualize this. There will be around 9 phases only. So initially there were around 309 rows, that means 309 bounding boxes which represent phases. So here there would be only around 9 bounding boxes which represent the phases, which actually is the case here. So when we print the output image, we would get the exact accurate prediction only. So this is how you apply the non-max suppression technique in order to achieve the accurate prediction, the single prediction representing a single object. So that's it from today.
Yeah, everybody knows that I'm breaking down. Everybody knows I ain't faking now. Everybody knows my heart's vacant now. Yeah, she hates me now, I made mistakes but now